proceed with example 2. The question is integrate from 0 until 1 2x plus 3 over x plus 1 squared. So this is obviously case B, which is repeated linear. So let's open up the partial fraction decomposition. So let's take the question 2x plus 3 over x plus 1 squared. And let's open up this one, the denominator. So we need to build up the repeated linear. The first one is x plus 1 and another one is plus x plus 1 squared. For your numerator, this is just one constant, a plus b. So now let's work out to equate your denominator. So you need x plus 1 squared. For this function here, you only have x plus 1. So you need to multiply another x plus 1, both in numerator and also denominator. And for this part here, you already have x plus 1 squared, so nothing should be done here, just write it back. So now we are ready to cancel our denominator. So let's multiply both sides with x plus 1 squared. Okay, so just cancel out your denominator. So you are left with 2x plus 3 equal to a x plus 1 plus b. So now let's work out in order to find a and b. Let's use elimination method. So in order to get rid of this factor here, we need to let x as -1. So let's do this. When x is -1, this is 0. And you are left only with b for your right hand side. For your left hand side, when x is -1, this is -2 plus 3. So this is equal to 1. Therefore, this is your answer for b. b is equal to 1. And let's do the next one. We need to find out what is a. However, we don't have any more factor here, so we cannot straight away eliminate our factor. So what should we do? We just let any number as our x, okay? So no need to choose any difficult number. We just use a simple one. So let x equal to 0. This is very easy. When x is equal to 0, your left hand side is 3. And when x is equal to 0, your right hand side is just a plus b. So now you know the value of b. b is equal to 1, so substitute it here. Therefore, let's rearrange. Your a is 3 minus 1. Therefore, your a is equal to 2. So now we have finished doing the elimination method. So we have the value of a and also the value of b. Therefore, let's straight away substitute in our question. This is our question just now. And we need to fill in the value of a and the value of b. So this is your new question here. So let's split the first rational function here. So 2 is a constant. Let's put it outside. So 2 integrate 1 over x plus 1 plus. And another one is integrate 1 over x plus 1 squared dx. Okay, so now we are ready to integrate this function here. Now let's see the first function. This is very simple. Let's just write 2 outside, and this is just ln in modulus x plus 1. So settle with that. Now let's straight away go to the second one here. Okay, so you have the denominator with x plus 1 squared. So let's use u substitution method. Let u as x plus 1. So du over dx is just equal to 1. And your dx is equal to du. So now instead of doing this, now we are integrating 1 over u squared du, or let's take this up. So this is integrate u to the power of -2 du. So now let's do this. Integrate u to the power of -2 du is just add 1 to the power, divide by new power. So it is just u to the power of -1 over -1, and don't forget to write plus c. Then let's fill in the value of u. So your u just now is x plus 1. So now let's substitute this here. So your final answer is 2 ln x plus 1 in modulus minus, okay, your minus here. And this is 1 over u. So let's do it. 1 over x plus 1 plus c. Okay, so this is your answer if you don't have any limit. However, our question, we have definite integral, which is the question said from 0 until 1. So let's rewrite our answer here without the c, and let's fill in the limit from 0 until 1. Now let's fill in limit of 1 first. So this is just 2 ln 2 minus 1 over 2. Minus, now let's fill in 0. So you have 2 ln 1 minus 1. Okay, now let's solve. Ln 1 is just 0. So 0 minus 1 is minus 1. Minus 1 back here is plus 1. Okay, just rewrite the first part. And let's solve this one here. So this is just half. Therefore, your final answer is 2 ln 2 plus half. So this is the final answer for example 2.